Hello friends, welcome to Susan and John MathTube. This is lesson number 8 and in this lesson we are going to discuss a very important topic, that is changing the order of integration. Okay, now we know that when we evaluate a double integral, or rather when we evaluate the limits for a double integral, we either use a vertical strip or we use a horizontal strip. And in change of order, what we do is we will change the vertical thing into the horizontal one or the horizontal one into the vertical one. If you watch lesson number 1, I told something very important. That is, our objective is, suppose the region of integration is from, let's say this is A and this is B. Okay, now our objective is very simple. We have to cover all the points from A to B, let's say above the x-axis and below the curve. And this can be attained by aligning all the points in a vertical fashion or by aligning all the points in a horizontal fashion. Or we believe that all the points are aligned in a vertical manner, and that is a vertical strip method, and all the points are aligned in horizontal manner, that is the horizontal strip. Anyway, to make you understand, it's better to solve one problem. So let's start. So please write, change the order of integration. I hope you're all ready with pen and paper. So please write the question. Change the order of integration 0 to a, 0 to root under a square minus x square, and I am going to put a dummy function f of xy dy dx. I put the dummy function so that we can focus only in changing the order. Now look at this, in exam they might ask the question like change the order and hence evaluate. And in such questions, you have to evaluate the integral. Okay, so I'll tell you the process. Number 1, you have to recognize the limit, and that will be very easy for you, because if you are following these video tutorials from lesson 1, you will understand that the limit of y will be written in terms of x. So that clearly gives me an idea that the inner limit belongs to y. And that means the outer limit must belong to x, because there are only two variables, x and y. Okay, now what we do is, we are going to write the limits one by one. So I am going to write y is equal to 0, y is equal to root under a square minus x square. Now remember, these are the, like what you call, the most important limits that will give us a clear idea about the strips. Anyway, the other limits are x is equal to 0, x is equal to a. And always remember, you should give maximum importance to the limit which has variable on both sides. I'll repeat, you have to give maximum importance to the limit which has variable on both sides after writing in this format. Now, what you do is, you manipulate this a little bit. Manipulate in the sense, you can square on both sides, you can cross multiply, you can play with it. And trust me, once you do that, you will get the standard equation of a curve. Maybe it will be a parabola, which you learned in class 12. Maybe it will be an ellipse, maybe a circle, maybe a line. And one important thing, you should be good with all the equations. And I'm sure most of you have already identified this is a circle. Okay, I'm going to square on both sides. And I'm going to take this x to the left side. See, x square plus y square equal to a square. A circle with center, origin and radius a. So see, they have given an integral, and from the integral we identified the limits. And then we wrote the limits one by one. Now we are converting the limits into picture. And one more very important thing, the inner limit belongs to y. That is, the person who made the question is using a vertical strip. The inner limit belongs to y, or let's think like this, the limit which contains the variable. Look at this, the limit which contains the variable. The outer limit doesn't contain any variable. Look, they are constants. The limit which contains the variable is y. That means the strip will be parallel to the y-axis. Okay, now parallel to the y-axis means we have a lot of possibilities. It can be here, or it can be here, or it can be like below the y-axis. So many possibilities are there. Now what we do is we will analyze all the limits. Now look at this, y equal to 0. Y equal to 0 means x-axis. Y equal to, this is a circle. Okay, so that gives me a clear idea. The strip is moving from x-axis to circle. So now I have a very clear idea about the strip. The strip is parallel to the y-axis. The strip has bottom point x-axis and the other point touching the circle. Now I am 100% sure this is not possible. So let me erase this. So this is not possible. So we might have a strip starting from -a to a, or maybe from 0 to a. Now look at the other limit, x varies from 0 to a. Perfect. Perfect. Now the picture is very clear. They are considering the first quadrant of the circle. They are considering the first quadrant of the circle. Take a look at this. Y changes from x-axis to circle, and x changes from 0 to a. So that means they are using a vertical strip in the first quadrant. So now I'll erase the remaining part so that you don't have any confusion. So this is where we have to focus. Now you have to write a dialogue in exam. After changing the order. Okay, once more let me make it very clear the process. You will be given an integral, and from the integral you have to identify the limits. Identifying the limit is very easy. You look at the limit which has variables. If you see x, that means the limit belongs to y. Okay, so identify the limits. And after identification, what you do is you write the limits one by one, like y equal to 0, y equal to this, x equal to 0, x equal to a, and give maximum focus to the limit or limits which will have variable on both sides. Okay, and by manipulating that, you will get a standard equation, maybe a line or an ellipse or a hyperbola or something which you have learned in your first semester or in your class 11 or class 12. Okay, now another important thing. If y has variable limit, the strip will be parallel to the y-axis. Now, by looking at all the limits, we will get a clear idea about the strip. And I identified that the region of integration is the first quadrant of the circle, because look at this, x varies from 0 to a and y varies from x-axis to circle. Now, changing order is a very simple process. You draw the same picture and you can mark the equation of the curve x square plus y square equal to a square in the first quadrant. The most important thing is when you change the order, you change the direction of the strip. You change the direction of the strip. Now this is 0, this is a, this is also a, but y equal to a, is x equal to 0, y equal to 0, y x equal to a. Now look at this. Once you have a strip parallel to the x-axis, y will be constant. So I can see that y varies from 0 to a. Y varies from 0 to a. And x varies from, look at this, you can check any strip. You can check any strip. You can draw anywhere in the region. X varies from y axis to circle. Now y axis means x equal to 0 and circle means we have to find the x value. That will give me root under a square minus y square. Is that clear? So the integral becomes, now what we do is we will look at the question and you forget about the old limits. You can forget about the given limits and you copy paste everything as such. Wait a minute, don't write dx dy, we will write it later. Now your job is you to plug in the new limits, and when you plug in the new limits, always remember the outer limit will be constant limit and the inner limit will be variable limit, or at least one of them will contain variable. And when you write, you have to write dx and dy because the inner limit belongs to x. That's it. This process is called changing the order. Now look at this. In your exams, they might ask questions like change the order and hence evaluate. And in such questions, what you do is you change the order, so up to this, and then evaluate this integral. Okay, I hope you got a rough idea. Now let's make it more clear. Okay, now let's go for another question. So please write question number 2. The question is evaluate the integral by changing the order. So please copy the question. Okay. Now look at this. What's the first thing to do? Identifying the limits. And that's very easy. Look at this. The inner limit contains the variable x. So that tells me the inner limit belongs to y. And that clearly implies the outer limit belongs to x. So done with that. Number 2, you have to write the limits very clearly, like y is equal to x square by 4a. Y is equal to 2 root under ax. X is equal to 0, x is equal to 4a. Now you should give maximum importance to the limit which contains limit or limits in this problem. You have to give importance to this as well as this. Look at this. It contains variable on the left side and the right side. This contains variable on the left side and the right side. And now the last thing to do is to manipulate a little bit. But remember, you should be very good with the equations from your class 11, 12 and first semester. And normally in the questions they ask, they will be asking questions from asteroid, ellipse, circle, parabola, hyperbola, anything can come. Okay, I can clearly see that this is a parabola. So the first one gives me the equation x square is equal to 4ay. And for the second one, I am going to square because manipulating a little bit means if you have a square root, you have to square on both sides. So the picture is very clear now. We have two parabolas. Now, once you have this, you can go for a rough figure. So y square equal to 4ax and x square is equal to 4ay. Now, the next important thing, the direction of the strip. Look at this. In the given question, y has variable limits. In the given question, y has variable limit. That means the strip will be parallel to the y-axis. That means the strip will be parallel to the y-axis. And it can be anywhere, but now I am going to read. By the way, wait a minute, I will use two different colors here. So I am going to make one parabola red, and the name of the parabola also I will write in red. X square is equal to 4ay, and the other parabola y square equal to 4ax. Okay, now, and the shape of the strip is vertical. Now look at this. This limit tells me y varies from this parabola to this parabola. Now x square equal to 4ay means, yeah. So you can see that very clearly the strip is vertical and the bottom point of the strip is x square equal to 4ay and the tip of the upper point of the strip is y square equal to 4ax. And the other things tell me the limit starts from x equal to 0 and the limit ends at x is equal to 4a. That is according to the question. So look, from the integral we identified the limits, and from the limits we got the equations, and from the equations we got the picture. Since y has variable limit, we can understand that the strip is parallel to the y axis. And now our job is to change the order. But wait a minute, before we change the order, we have to write the y coordinate also here. X equal to 0 means y equal to 0 because this is the origin. Now x equal to 4a means this point will be, let's plug it here, 4a the whole square is equal to 4ay, cut y equal to 4a. Now your job is very simple. All you have to do is you have to write after changing the order of integration. So what will you write? After changing the order of integration. Draw the same picture. One difference, don't draw the vertical strip. Instead, you have to draw a horizontal strip. That is a strip parallel to the x-axis. Okay, now it's very easy. We have to write the limits. You can draw the strip anywhere you like. You can draw the strip anywhere you like in the region. And it clearly tells me x varies from, x means this direction. X varies from black parabola to red color parabola. Look at this parabola, it is mixed color, but please understand I try to make it in red. Yeah, so black parabola to red parabola. Now the x value in the black parabola is y square by 4a. The black parabola equation is over here. The x value is y square by 4a. 2. The x value in the red parabola is square root of 4ay. Okay. Now the last thing. The last thing, it write the given integral as such. Write everything other than the limits. And don't write dy and dx. Now what you do is you plug in the new limits. Oh, I forgot to find the y values. It's clear, y varies from 0 to 4a. You can see that here. See, if you extend the strip, it will be very easy to understand. Y varies from 0 to 4a. Now let's plug in the new limits. Y equal to 0 to 4a, and x varies from y square by 4a to 2 root a root y. If you are wondering where that came from, it's over here. I took the square root. So root 4 is 2, root a is root a, root y is root y. And I should write in the order dx dy. Now look at this, the inner limit belongs to x. So I hope you remember the question. It is not change the order. It is change the order and evaluate. So change of order is complete. Now one thing left, we have to evaluate it. So it is like y equal to 0 to 4a, integral dx is x. By the way, so many students in class always ask me, why should we change the order? Why don't we evaluate the integral as such? The answer is very simple. Sometimes, not everywhere, not even in this problem, sometimes when we change the order, the evaluation of integral becomes very easy. So tomorrow when you are busy integrating in some application problems, maybe changing the order will help you. So in the mathematics class, what you are learning is you are expanding your skills, you are expanding your integration skill. So we are learning one more technique so that when you learn some application in other subject, in your applied subject, you may be able to apply change of order. So remember, in mathematics, you may not see any advantage. Look at this. If you evaluate the original integral also, it looks the same. And if this integral also kind of like looks the same, so therefore it is same. But remember, there are some integrals, once you change the order, becomes very easy to evaluate. So basically, you're just expanding your what you call integration skill. Yeah, okay. So now you can plug in the upper limit. So that's going to give you integral y is equal to 0 to 4a to root a root y minus y square by 4a dy, and that will be integral y equal to 0 to 4a to root a y to the power 1 by 2 minus 1 by 4a y to the power 2, and that will be 2 root a. Now to integrate this, that will be y to the power 1 by 2 plus 1 by 1 by 2 plus 1, that will become 2 by 3 here. I will plug in the limits right away. 1 by 4a, if you integrate this, it will be y to the power 3 by 3. I will write 1 by 3 outside and put the limits. I hope you can understand these steps. So 4 by 3 root a, you plug in this limit, so you get 4a to the power 3 by 2 minus 0 minus 1 by 12a, 4a to the power 3 minus 0. Now if someone has doubt like what is this x to the power 3 by 2, let me put it like this. A to the power m, the whole power n gives us a power m into n. That means you can write this as x to the power 1 by 2, the whole cube. But x to the power 1 by 2 is root x, and root x the whole cube will be root x into root x into root x, or that is nothing but x root x. So using that logic, I am going to write this as 4a root 4a minus, here what happens is there will be cancellation. I think I should write it like 1 by 4a into 1 by 3 itself, so that I can see that 4a gets cancelled. And this is going to give me 4 into 4 is 16, 16 into 2 32, 32 by 3. And a that will be a square minus 16 by 3 a square, which gives me 16 by 3 a square. Now let's go for one more problem, very important. Okay, so please write change the order and hence evaluate. So please write change the order and hence evaluate. Integral 0 to 1, integral x square to 2 minus x, x into y into dx into dy. So first things first, let's give it a name. So you can start like this. Let the given integral be capital I is equal to 0 to 1 x square to 2 minus x into y dx dy. So what should we do next? Identify the limits. Okay, clearly the inner limit belongs to y, the outer limit belongs to x. Now the third step, what you do is you write the limits one by one, but very clearly, because we are going to construct equations from these limits. And you should give maximum focus to the limit which has variable on both sides. So look at this. This is the parabola symmetric about the y-axis. And this is the line, because I can see that degree of x and degree of y is 1. And it is pretty easy to plot, because the line will be x plus y is equal to 2. And I am going to write this in the intercept form I explained in lesson 5 or lesson 6. That means this line will cut the x-axis at 2 and the y-axis at 2. In the sense 2, 0 and 0, 2. Okay, and if you want, you can solve them and find the point of intersection. X square is equal to 2 minus x, and that will give you x square plus x minus 2 equal to 0. You can use a calculator. So the points of intersection are 1 and minus 2. So the corresponding y coordinate will be 1 squared and 4. You can plug it anywhere you like. So the y values are here. Now we can have the picture. So picture goes like this. So we have a parabola. Okay, and we have a line which cuts the y-axis at 2. So it's kind of like this. Okay, so and the point of intersections that we got 1, 1. So let's say this is x equal to 1 and this is y equal to 1 and minus 2, 4. So this is, so x is minus 2 here. Look at this, y has variable limits. Who has variable limits? Y. Okay, so the strip is parallel to the y-axis and it moves from 0 to 1. And the bottom point is on the parabola and the top point is on the line. So I get a clear instruction, I get a very clear instruction from these limits. It moves from 0 to 1, it is parallel to the y-axis and the bottom point of the strip is parabola and the top point is the line. And that clearly gives me the indication, the required region. I am going to shade it with yellow color. So this is the required region. I'll tell you why. Look, it is parallel to the y-axis, the bottom point is on the parabola and the top point is on the line. And the equation of the line is x plus y is equal to 2 and the equation of the parabola is y is equal to x square. Now what we do is we draw the same picture. We will draw the same picture and we will write a dialogue after changing the order of integration, and I'll paste the same thing. Now remember, when you change the order, if you have a vertical strip, don't forget to make it a horizontal strip. Now I can see a big problem. Look at this. I tell every time you can draw the strip anywhere. You can draw the strip anywhere but parallel to the x-axis. But I am noticing something weird. Did you notice that? Something is weird. Look at this. When I calculate the limits of x, I can see that something is wrong. Look at the red, the red ones. It is from y-axis to parabola. Y-axis to parabola, y-axis to parabola, y-axis to parabola. But after y is equal to 1, the story is different. It is from y-axis to line. Look, y-axis to line, y-axis to line. Nothing to worry. This actually means the new integral is going to split. This actually means the new integral is going to split. And I'll tell you a very easy method to write the new limits. First of all, let's write the limits of y, because y will have constant limit. Never forget the logic. Whenever you draw a strip parallel to the x-axis, y will be a constant. Now look at the red limits. Y varies from 0 to 1. In the second integral, I will write y varies from 1 to 2. In the first integral, I will write x varies from y-axis to parabola. In the second one, I will write x varies from y-axis to the line. That's it. That's it. So remember, whenever you have this situation, it means the original integral will split into two integrals after change of order. Now one more thing to do, we write everything properly. So look at this, the given integral becomes, in the exam don't write like this, write it neatly. I am writing like this so that you will understand very fast. So y is equal to 0 to 1 and x is equal to, come on, y-axis means x equal to 0. And parabola means, what is the x value? X value is root y. Plus double integral, y is varying from 1 to 2. And again, y-axis means x equal to 0 and line means, let me check, x is equal to 2 minus y. That's it. Now you have to fill it with something. I hope you wrote the question. Where is that? Where is that? Where is that? Yeah, x into y. Yeah, okay. So I'm going to write x into y dx dy, x into y dx dy. Now the sad part, change of order is over, but now we have to evaluate, because the question was evaluate by changing the order of integration. So let's start, and we are going to integrate with respect to, last time I promised you, by changing the order sometimes integrals become easy, but as an example I am giving you the exact opposite. Yeah, but like I told you, this is just increasing your mathematical skill. Okay, so this becomes integral y is equal to 0 to 1. We will keep that y here and integrate x square by 2 within the limits x is equal to 0 to root y dy. X means x power 1 and the limit 0 to root y. Now take a look at the second integral. So I put a plus sign and y varies from 1 to 2, x square by 2 and x varies from 0 to 2 minus y dy. And now let's keep this 1 by 2 outside. So 1 by 2 integral y equal to 0 to 1 y into, plug in upper limit, root y the whole squared minus 0 squared. So you are going to get 1 by 2. When we plug in this, you are going to get 2 minus y the whole squared minus 0 squared dy. Now time to simplify. 1 by 2 integral y equal to 0 to 1. This will be y square dy plus 1 by 2 integral y is equal to 1 to 2 y into 2 minus y the whole squared, 4 minus 2 into 4y plus y squared, and that will be 1 by 2 integral y equal to 0 to 1 y squared dy. We can integrate, but let's simplify this and integrate together. Y is equal to 1 to 2 4y minus 4y squared plus y cube dy. You can do the integration by yourself now. Anyway, I'll go a little bit fast. You try it yourself and check with the final answer. 4y squared by 2 minus 4y cube by 3 plus y to the power 4 by 4 within y equal to 1 to 2, which gives me 1 by 2 into 1 by 3 minus 0 plus 1 by 2 into, you plug in the upper limit, it will give 2 squared, 4 into 2, that is 8 minus 2 cube, 8 into 4, 32 by 3 plus 16 by 4, that will be a 4, okay, minus 2 minus 4 by 3 plus 1 by 4. Okay, take a calculator and simplify. Anyway, I got the answer 3 by 8. So that's it. This is a very important problem. And one very important thing, these videos will help you understand the subject. But if you want to get marks, once you complete the video, take some past year question papers and try to work out the questions. And if you want to make it more clear, after watching these videos, you take your textbook, any textbook you like, and try to work out a lot of problems from that textbook. If you are able to work out those problems, then that means you understood the subject properly. So remember, if you just watch a video, you will understand, but you may not get marks. So if you are really looking for marks, make sure you watch the video, understand the subject, that's great, and then practice and get good marks. Anyway, I'll be back with another very important topic for you, that is changing Cartesian integrals into polar integral. So we'll meet very soon. Till then, bye.